L'archetto. Sto parlando? Oh, finally.
Right.
What's your name again?
Gemma. Hentsch. Just Hentsch. Yep.
Hi everyone. We are going to begin the presentation of Emma Hentsch about using Python in the modern Warzone. Please listen, turn off your cell phones and enjoy.
So, unfortunately, now I've actually got you here, I do actually have one teensy-weensy confession. Although this code could be used in the Warzone, the environment I was using it in was event-based stuff. So, it's a very unfriendly coding environment, and it was described to me as a Warzone when I started working with it. And they weren't wrong. It wasn't quite as bad as they initially indicated, but it was okay. It wasn't okay. It was stressful, crazy, and exactly how I would imagine if you're trying to make your code survive in very resilient, problematic situations. I dealt with three main problems, which I'm going to try and summarize as much as I can into space. One of the biggest problems we suffered from was the fact that we had a very overclocked, very intense network situation. Now, some of the stuff we did actually do over some very stable architecture. We used 0MQ backend for a lot of the messaging systems. But for a lot of our messaging, the amount of traffic that was going around a stand, if you're using every single message that's going from every single device being broadcast to every single device, you end up with a situation of network clogging. So one of the ways we got around this was, rather than having a bigger network connection, wonderful idea, nobody ever liked that idea, was the fact that we began to go a little bit more low level. And so, being a web developer, I did my network theory. I knew I've used it. Sorry. I've done all the theory, done a few practicals at university, and I'd never actually ever had a use case for doing it. I knew it was there in Python, but to be honest, it's actually remarkably doable and remarkably efficient. If, under an idealized situation, if you've got a reliable network, you can get, with 3 packets, you can send a useful message. Because you can send, receive, confirm. And that's not, we're not talking, and you can fit an extraordinarily large amount of data if you think about it, if you structure your data right. I mean, for example, here's a, where are we? This one. You can send as much, provided you're structuring your systems right, you can be sending rich messages around without having to worry about all the other context and all the other weight. As I said, this is not always the best solution. This is a solution for a problem, but if you're having a problem with network connection, it is a viable and simple solution. And just to give you a rough idea, I'll just take you through some very basic Python for doing this. Over here, this is the code you need to send a message. So you open, no, actually that bit there. So you open up a connection, send a message, send the packet, and if you want to listen for a response, you can listen for a response. It is literally that easy. On the other side, it's implementation of the factory pattern. So you have a socket server, and then you give it a handler method when you start it up. Let me pull that. And you can deal with that as simply or complex as you want to in that area. And just to give you an idea, 2 bits of code, so run the server. I think that must have come through already. And run the sender. What? I think this is really going to be my day. Oh, sorry, actually it already did come through, so I'm being blind. Yep, sorry, I got the message. I had the windows open. So you've got, here's the sent message received, but it's being responded back to, and it's doing exactly the same thing on the other side. You can go up a level. You can do it at the TCP as well. If we've got time at the end and people are interested, I can show you the same implementation in TCP, and you can get more resilience. But if the objective is to get as simple as possible, this is the way to do it. If you want a little bit more resilience, one of the patterns we used in this was you literally broadcast 5 packets with your UID, so you're never going to notice you've got 2 messages through, and even then you're dealing with a trivial amount of network traffic compared to what you could be dealing with in a rich communication environment. And actually related, I don't know if you guys saw the previous example, this actually can be very easily tied together even into web services. I mean, one of the reasons I got this method up, this is just a very basic Flask app for you poke the directory or you poke the path and it sends out a network packet. And I actually have done some fairly horrific stuff with this because one of the other troubles I had to do was I had to reverse engineer a few systems and tie them all together with Python, which I'm going to try and cover in the next little bit. And part of it involved presenting a web interface that could be controlled that dealt with dealing with a system that could only be talked to by TCP. And yeah, we like to live in worlds where everybody implements a decent, workable, tested API, but how many people have dealt with situations where they haven't had a well-documented function? Oh, and this is a very, very, very important thing. The person who wrote a piece of software, even if they were paid an obscene amount of money to do it, does not always know how it works. I ended up having a situation where I met the people who built the LED wall software I was controlling, and they told me I've been getting some weird warning messages back, and they said, "Oh no, you're opening up a connection and then you're closing, opening up another connection." And I thought, well, and what you need to do is you need to keep the connection open, and then you can have. And then you just send messages down and down and down. So rewrote the software to do this. And then when it went live, in New York, in the middle of a press event, the system crashed. And I had no idea what was going on until I realized that's not how the system works. Their system just doesn't know how to send messages back properly. And they think it keeps connections open, but what ended up happening was because they kept my connections open, I ended up having about 10,000 TCP connections wide open. And the system did not like that. So that's that. I want to try and make sure that I've left enough sides to both sides, so I want to carry on with the other side of things, which is more, and then I'm going to come back to if anyone wants me to talk a bit more about networking, I can come back at the end. But the second issue is, I think, actually one that's more directly applicable to people, which is the problems of, well, there are lots of ways to describe this. I start talking about lightning, because the most apt example I could think of this was when the supposedly wonderfully stable, bulletproof, rock-solid US 1 class availability zone of Amazon went bang because they didn't think about Mother Nature. And most of the stuff I've done with this involved where you can actually have somebody put a spade through a power line, or a network cable, or somebody, when they were tired, accidentally yanked a cable back out of the back of a server because they were working behind it. Names will be mentioned on that one. And that person had been up for about 40 hours and was very, very tired, but we will not mention that one again. But to a certain extent, this is still a real problem, even in situations where we're told there is reliability. We're told these situations exist. One of my first disaster situations was back in about 2007 when I was working for 2006 when I was working for a very shady e-commerce company. And I don't know if anybody was in London back then, but there was a massive power fail over, and one of the major data centers in London, their systems didn't work, and we lost half our data. Now,
backups, right?
shady. Actually, that was the time I learned how to do .NET, because they didn't know how to do .NET, and we needed to fix some code. So it's not actually that difficult. I mean, at least the language isn't that difficult to understand. Never put .NET in your CV either. Even if you think you understand it, you will be bothered for the rest of your life by recruiters trying to say, "But you can do .NET." No, I was using that as an example of my flexibility. I do not do .NET professionally. But, so the issue here is not so much the reliability of the hardware or even the operating system or even your software. That's not what we're talking about. The problem here is what happens with your system when it comes back from the dead. And to be honest, I am very much a fan of building state machines in my systems. Not always as beautifully and elegantly as I'm sure my computer science professor would like it to be, but that's actually what I've done in most of the systems I've done in these situations. And also, it's just I find it's a useful, helpful pattern for doing it, for dealing with multiple systems talking to each other. The trouble is what happens if when you're coming back from the state, or you're coming back and you're halfway through two states, and your system doesn't know how to recover. What you've got to look at, I mean, I took my initial route was to make my system as reliable as possible. I was using a combination of Redis on write everything out before you even admit you've got it mode. And the other, because I don't know if you guys have had much experience with Redis, but there's, at least at the time I was doing it, there were three modes. There was the, it's in memory, you shouldn't really be relying on me. The, I will write this out every second, and once I've responded to it, I've written it down. Once I've got the message, it's written onto disk, which is a good way to get started, but it still doesn't deal with every situation. And the other method I was using for one of my other areas was a RabbitMQ backed Celery. And I have to say, RabbitMQ is, I literally yanked the power cord out of the back about 10 times and just saw how the state was, saw how it was maintaining the state. Every single time it came back from the dead without even so much of a complaint. But even then, if it's in between these states, you've got to think about how to do it. Now, I have some bad code, and I have a lot of notes about how to not do this in future. So, well, I mean, there's various solutions on the way to do this. The most reliable way I found to do it was you actually had to almost think about it a bit like migrations, in the fact that you always had a rollback state. Actually, I suppose it's even more like you just talk about. Sorry, I get distracted in my head way too easily because I start thinking new ideas. What you've got to effectively do is say to the system, when you're initiating the states, that you effectively have a entry state and an exit state to any situation, to each state change. And that any changes that happen in mid-state are not effectively on the system, sorry, it may not be as close as I think. So, okay, I'll roll it back to a slightly simpler thing. If you have your states set on the system, if you have your states set on the system, you don't remove the old state marker and the old state until you've actually completed the state. The final step that sets the new state on the next stage cannot be set until the previous state has been done. So then even if you're halfway through whatever is going on, everything should be written in such a way to, if it stops halfway through, if literally the ground falls from out beneath you and you come back again, you can still start from the beginning of the state change. Now I'm trying to think of it. I do have some, as I said, bad examples of this. I mean, this is my, this is actually one of my state machine it was using Redis as the persistent state between about six different pieces of code that were running in parallel, that were running for different components of it, and it's actually using some networks debugging stuff as well. Is that the one I wanted to use? Yes, that is the one I wanted to use. And literally, what I was using there was actually putting flags on the different. The flags were actually a composite of the state. If you in this one, which is a very simple situation, you had. What you have to imagine is you've got a Final Cut type timeline that's actually being live played. And from that, at certain stages, certain messages are being sent from the system that this is handling and passing to other areas of the system, and including making some decision making. So in this one, this is actually a much more simplified version of the code because I took out all the stuff to do with the video stuff. There's video editing, there's messaging, there's messaging going to, there's stuff going to YouTube and everything else like that. That's all been taken out of this, just trying to limit it back to this basic situation. And you've got all the other services looking at that single the Redis instance for the. I'm just actually using it as a persistent key value store that can be accessed from every system from these different systems, but. What I've tried to do here as much as possible is when these state changes happen, they're being limited. If one of them doesn't work, then it should have got to the next state change before the next state has happened, before a crash has happened, because I'm trying to keep them as small as humanly possible. Unfortunately, this is what happens when you don't. This is actually this is a small part of one of my reverse engineering projects I had to do, which is a After Effects. Basically had to reverse engineer After Effects to be able to be a remote image composer. I didn't make this decision. This was what I was told I had to build, so I built it. But to a certain extent, one of the problems with this system was the fact that the whole system wasn't a state machine. This actually worked fairly well and was fairly reliable. The trouble was the machines that were talking to this, because there's other lines of code which I can go through if I have time. It took messages, took a UDP message, and then which would then contain information about how to do a composition. But from that, and then when it had the composition, it would then transmit that message back again. There's a very big trouble here, the fact that the other machines were not operating on the same principle, that it was asynchronous. And as a result, this beautiful system, it worked. I mean, we had problems, but it worked. But part of that is literally a case of you've got to make sure the fact that if you're going to make you have to make these assumptions. You cannot make assumptions about other parts of the system following the same patterns as you do. How are we actually doing for time? Ooh, a little bit quicker than I planned to. Right. Let me think. I was drastically worried about running over, because I always talk, and then it's normally your job to kind of tell me you should have finished 10 minutes ago. So I was trying to keep myself a little bit limited. But so I guess the next thing to cover, I suppose the next thing is I could. Sorry. As far as, sorry, I suppose the best thing, and hopefully this will be the more useful stuff because it will be more related to you, what you're interested is to how this applies to what would people be more interested in seeing more of? Would it be more about the state machine side of things or more about the networking side of things?
State machine.
Raise some hands.
Okay, so more networking? More state machines? Okay.
Guys, we need more hands.
Okay, so we're going to have to... So... Right. See if we can pull up... See, this one... Come on. Right. Oh, that's why it does that. Right. That's what I was looking for. Okay, so this, as far as going to the networking side of things, this is actually one of a slightly more. This is a implementation of. Right, this is actually an implementation of what I was talking about, of reverse engineering a badly documented TCP/IP protocol, or API. This is my original notes. Well, this is all I had as far as documentation went. And from that I had to kind of guess what would change states, played around, built a few of their control systems, and then began talking it to see if I could work out what it was. This does actually fully implement the API, but however, a lot of this we never actually ended up using, but it fulfilled it enabled the facility to work. This is the fixed code. This isn't the stuff which kept keeping connections open. But so what I ended up doing is, because it was a very simple messaging format, just do a wrapper for each command, pass it through to the messaging system which is trying to talk through, and this wrapper was actually implemented by several different parts of the system, because all of them were capable of talking down to the compositing system, but sorry, not the compositing system. Sorry, my brain is. I apologise for my speaking. This is actually the first time I've been speaking, so it's also the fact I'm incredibly nervous, hence why I keep stammering and stuttering. This was actually this interface was actually I implemented this actually as somewhat of an interface that was then implemented by the web interface that was being controlled by the people on the stands, the messaging system that was being talked to it was receiving messages back from the watch out software, which is the LED control software, and also there was another bit that was handling RFID calls, because people had user accounts. So, for example, they could see. They were able to have personalized information. So, for example, there was all these things. So, if you had your name, it would say, "Welcome Gemma, and actually if I get a chance, I will, at the end, I will show you actually what the end product of one of these was. There weren't really any issues on this one once I'd actually figured out how this was going to work. The main weirdness was the fact that I was working on the principle, the fact that there was no documentation of how the system was meant to work. I mean, that is what the documentation said. That's all I had to work with, and it was a lot of guesswork from that. Incidentally, this is more documentation than I had when I was working on After Effects, well, admittedly, I was breaking in every unholy way to make it work, but when you have an XML format that somebody's going to think about using, you should probably document it. So let's see, where's the next bit I was going to do? So what I was going to do was just talk about, show you the TCP implementation. Sorry, where are we? Okay, so this is actually show you the differences, and to be honest, they're both implemented. These are both primitive servers. There is both forking and threading servers also included in the system. These are all in the Python-based library. But this is just I was just trying to focus on the most basic parts of it. So the main difference between TCP handling and UDP handling is that you're dealing with a stream rather than a single packet. If you're dealing with UDP and you want to send more information, you can certainly send more information, but you're going to have to build it on top of that. It's not the response. There's a reason why people use TCP and don't each time try and reinvent the wheel when they want to send much more complicated information. Although UDP does have its advantages. I've been having some fun working on at least a theoretical principle for using, I don't know if you guys have seen much on UDP acceleration. Sort of, if you're involved in content delivery networks, it's one of the hottest properties because it's all involved in how can you maximize your bandwidth for sending files around. And I think the last time I had somebody trot out a solution, I think it was something like 10,000 a month to use the software. But you're dealing with huge files and basically major media companies. So I'm just thinking more which is the best thing to show for the next state machine stuff.
I'm curious if you're talking about state machines, if you maybe have an example of when you ended up with corrupted data after a crash.
Can you please repeat the question for the word?
Pardon?
Can you please repeat the question for the listener outside?
The question was, any examples of when I had a state machine and I had corrupted data? Actually, for the most part, we were fairly lucky, but part of the luck was that aside from on our press day situation, we didn't really have any mission critical data. Although what ended up happening was actually maybe if I show you an example of what we're actually producing from one of these bits of software, it would actually be not that one.
Let's see which video that is.
Let me see. Right. There are about 1,000 of these for Detroit, 1,000 of these from. Actually, wait a second. Better than that, I will show you the. The trouble is, I do actually have one with me in it, but it was done in Beijing, and the person who re-edited the video for Beijing, I want shot because. You'll see what I mean. You'll see what I mean in a second. Right. Fortunately, it's full screen. Oh. Which network am I on? I'm sure I'm on the. Oh no, I'm on the. No wonder I'm on the.
It's a good example of network congestion.
Yeah. Right. I Okay, now we're in business. I'm being risky. Right. So this is one of the part of the user customization aspects, was the fact that the name, if you had your own if you had your own registered account, I'm not responsible for video compositing, by the way. I was controlling all the system doing it. So the worst amount of data problems I had ended up being when we actually had news crews on the stand seeing this. And the whole process of this was once the video had been recorded on another box, which is also being controlled by the same software, and then it was meant to be put in another celery queue that was being pushed up to YouTube and then attached to the user's account on the card. Unfortunately, this didn't work on press day, and then we ended up having to work through about 500 files, work through about 500 files to find the originals, cut them, individually produce them, and then push them back up to YouTube again, which was, it was fun trying to do.
Was there a journal in place that you could refer to?
Pardon?
Was there a journal in place of operations?
To a certain extent, this is another issue of not running other state machines. Other people not running the same state machines. My system knew everything that was going on, but to a certain extent what it said was start recording a file, stop recording a file, and you get the file name back again. If that doesn't happen, my system didn't have any way of knowing what was going on the other side, because to a certain extent it was another blind machine, his primary response. To a certain extent, a lot of this stuff comes from when I was first told about this situation that we were going to deal with, I designed a system that was inspired by the people who, I presume most people have read Rendezvous for Rama? Rendezvous for Rama by Arthur C. Clarke. To a certain extent, it was basically described as a spaceship designed for moving between star systems, which had multi-layers of triple redundancy. I went to one layer of triple redundancy, and then I was told, no, we don't have the budget for that. Tried for double redundancy, still didn't have the budget for that. So, to a certain extent, there are idealized ways to work on this system, this situation that a lot of these situations shouldn't have happened. But to a certain extent, when you're working in about 3 months to build this stuff from absolutely nothing, you just get it's not possible. So, you can try and minimize the issues by clever planning. You may not always be able to get something you may be able to get something that's 99% perfect. You probably cannot get something that's 99.99% perfect, but you can definitely get better than 75% perfect, which is kind of where we started in this principle. So from there, I'm trying to think what else to go on to. So I have managed to be quite quick, a lot quicker than I planned, but obviously the third problem in this situation is the fact that there is a finite limit to how much caffeine you can actually drink. That eventually it stops working after about 40 hours, stops working. I guess from there, has anybody got any other questions? I've got two. Sorry.
My question is about why you decided to use Python instead of any other language?
To be honest, it's one of my. I think the nicest features about Python is it's very good glue code. We had a lot of a lot of hardware that's being written in, I mean, we had stuff that was talking to GStreamer that was actually being interfaced through using a Python wrapper into Twisted that was talking to me. That we had, I built these network libraries. The initial versions of these I built, I think, in 2 days. I obviously went through numerous iterations to improve it, but it's a very quick language for building the glue code to tie far more complex, far more customized and optimized systems together, and to try this stuff out without. I mean, when you can actually do this stuff when you can do this stuff in IPython, as the previous person was saying, you can develop this stuff. You don't have to compile stuff. You don't have to try. Oh, maybe I got the wrong setting. I've got to go all the way back to. You can literally play around with live code and try and build this stuff and even also debug it. I mean, I've used an IDE with every language I've ever used except for Python. I use a syntax highlighting text editor, and I use IPython. There's been probably only one situation where I wish I'd had an IDE, and that was mainly because the search function on TextMate was rubbish at the time. And it's not always the right tool for the right job, but in a lot of situations it is.
Hi, thanks for the talk. I noticed you used Celery, which is a task queue combined with RabbitMQ.
Yes.
Did you run into any serious limits while using that?
Celery, no, we did. Well, I'm just trying to... Actually, no, because we were experiencing some network traffic issues. So what I ended up doing was I ended up writing scripts to basically try and overload my compositor in every way I could possibly conceive. And I probably loaded 10,000 composition jobs onto it in about, and literally all that was happening was, I can actually show you the code that was doing it. If I can just pull it up, I've got a window. Where did I put that window?
No, I mean, there were no significant problems with race conditions, maintaining state across nodes.
We didn't, the configuration we deployed never had multiple nodes. I built when we were looking at the system being a bottleneck, which it didn't turn out to be, one of the solutions I worked on was literally using a single RabbitMQ instance and using several nodes to do the composition, and it handled it pretty transparently on the test runs. There are other backends which, to be honest, there are certain situations when even the SQLite backend will work just about. The Redis ones had a lot of work recently, but the most reliable one, as I said, I was literally trying to break this system and yanking cables out the back of it. RabbitMQ kept it, did what it was meant to do. So, any other questions? Oh, sorry, was that? Yeah, thanks.
Don't worry.
Okay, then that was it. Now, in 10 minutes or so, we'll start the coffee break. And I want you also to recall this evening there shall be the pie barbecue. Anyone who bought the ticket is suggested to come. And and I should speak a lot. Well, that was it. Thank you.
Thank you, and thank you for coming.
Congrats on your first talk.
Thank you.